Okay. Well, hello everybody. My name is Talib Oliver, and I'll be talking about the Delta X UAVSAR wire level change maps derived from InSAR. And before I start, Marc already explained some of the advantages and how the UAVSAR works. But this image, I think, is very good to exemplify the advantages of UAVSAR. In this image, we can observe in the blue patterns wire level change through the delta, as well as many channels. And that precisely is the advantage of this data set, that it provides us information in areas where we cannot use a tide gauge. And then we can use these type of images to add to the wire level change information for models and other uses. So this slide shows the summary of the data acquisition. We had two campaigns. The spring campaign, which was flown between March 27 and April 18 of 2021. And then the fall campaign that was in September between the 3rd and the 13th of 2021. Here, these frames show the flight tracks that were acquired that cover the whole region of the delta of the Wax Lake and the Chafalaya deltas. And this chart below is just a summary of how much data in volume as well as in files was generated for all this acquisition. And I'll talk a little bit more about each one of these data sets in the next slides. So our first and base source of information was the L1 product, single loop complex, quad polarized acquisitions. And they were divided, they are not even, depending on the type of weather conditions and other factors. Some of the images were acquired, in some of flights were more images and some others were less. So this is a summary of the full acquisition. And we use these single complex images to generate interferograms. These interferograms, later we will use them to generate wire level change maps. So if you're interested on the SAR products, you can find them at ORNL in this link below. And we also have provided some training notebooks, Jupyter notebooks, that can be used for anybody that is interested. You can access it also through ORNL. There's videos as well as the notebooks available. So you can download your data set and play with the notebook and see how this data set works and start also interacting with the product. Then the next products are the L1B and L2, which is already the first derived. It's interferometric products. These products were generated between nearest neighbor plus 1 and nearest neighbor plus 2 pairs of images in the VV polarization. What this information shows us is basically wire level change between each SAR acquisition. And we use these ones to generate a time series later on that we also have as a product. But for whomever may be interested in the interferometric products, they're also available at the ORNL DAC. And we provide the interferometric amplitude, the wrap phase, the interferometric coherence, and the unwrapped phase. And these products are in radar coordinates as well as in geocoordinate grid, all available at the ORNL DAC. And as you can see in this slide, the volume of the data is starting to expand because we generated nearest neighbor plus 1 and nearest neighbor plus 2 interferograms. Each flight line has then basically tripled in size. So for whomever is interested in interferograms, we generated for the spring campaign a total of 303 interferograms, and for the fall campaign, 178 interferograms. And we also provide Jupyter notebooks and training in video, also available at the ORNL DAC. We also provide some basic explanation for people that wants to get familiarized with what the interferometry looks like and what it means and how to use it, as well as examples on how to plot, display, and get useful information out of the interferograms. So from these sets of interferograms, then we generated series of time series of water level change. This is our level 3 product. For our level 3 product, we also provide trainings for friendly to users in Python, and there's videos as well in the RNL DAC. And these trainings, what it contains is how to display the images, how to plot a time series of the water level change, how to zoom in into the image and maybe create a subset of useful information or information that may be useful for you. So I highly encourage you to visit these workshop trainings because they will be very helpful for anybody that wants to use the data to start playing with it. And this is just an example of how the level 3 InSAR-derived water level change looks like. Here I'm showing the time series of InSAR. We can see how we have green and bluish colors in this part of the Atchafalaya region, sorry, of the Terrebonne, East Terrebonne region. These images were acquired April 12th, which means that in this map here, those blue lines show all the acquisitions used for the generation of this time series. We also have other acquisitions at a different tide stage. So depending on what you want to observe, you can choose your date. But for the case of this one, we observed that the tide was going downwards, and that's the direction that we see. The blue color shows low tide or a decrease in water level. And when we observe the InSAR compared to the tide gauges around, we can see that the trend also follows closely. Both InSAR and tide gauges around the area are following the same direction. A different example in the West Terrebonne, this time series is from April 6th, also in this area here of the tide. And the frame location is in this corner, just so that you guys can get a better reference, because this is plot like this so that we could fit better in the slide all the information. But the point of this image is to show how we can capture also increasing water level. And the comparison below shows the InSAR water level changing together with the information of stations in the nearby area. So hopefully you guys can find a data set that you find interesting and do these type of plots for your projects. And these type of plots, you can, again, use the notebooks that are available online to try to replicate this type of plots. So this is a summary of the links where you can find the workshop, the videos, the tutorials. And then another very important data set that has been created was the open water channels based on the UAVSAR as well. These maps were mostly generated by Dr. Cathleen Jones and Bhuvan Varugu. And they take advantage of the fact that the coherence and the amplitude are sensitive to the ground surface characteristics. So they were very useful to then create a very dense map of channels in open water regions. The products are separated in two, one for Atchafalaya and one for Terrebonne. And this is the summary of all the data that was used to generate these masks. And basically, both fall and spring data was used to generate these masks because one of the seasons, I think it was the fall campaign, was basically more wet, which meant that the water levels were higher and the channels were more clear, or channels that may not be very clear in one of the seasons was clearer on the other. So by using both data sets, we were able to generate clearer masks of channels. And these are just some examples of how detailed these masks are and the level of channels that we can see. The resolution of these maps are 10 meter pixel. In comparison, the interferometry products, the resolution is 6 meter pixel. So these are slightly coarser, but still very high resolution. You can see here the comparison. The black and white is the mask, and the Google Earth image in the bottom or in the right side. Again, another comparison of how clear and dense the channels are in the region. And this dataset is also available at ORNL. So please feel free to take a look and play with it. And just to wrap up and to summarize, this is how all the acquisition looks like. You can find all the information at these links. The dataset includes basic information and user processing information, as well as acquisition information, but also the training links contain explanations and exercises that you guys can use to take advantage of this data set. So please feel free to play with it and start using the UAVSAR Delta X. And that's it for me.